Okay, this is chapter 5, section 1, the angles of triangles. So first, let's talk about what a triangle is. A triangle is formed by three segments joining three non-collinear points. For example, A, B, and C are each of our points, and our sides are AB, BC, and CA. So the distance between AB, BC, and CA, that forms our triangle. So it has three sides, 3 points. The point where the segments meet is called a vertex, and its plural is vertices, okay? We're going to be referencing those a lot. Our vertexes here are A, B, and C. In other words, the edges or the corners of each of the triangle. The angles that are formed inside the triangle become angle A, which is this angle B, and then angle C down here, okay? So we've got A, B, and C as our angles. Okay. All right. Now, there's three different kinds of triangles. There's a scalene, which means no sides are the same. There's isosceles, where at least two sides are the same. And then there's equilateral, where each of the sides are the same. And we have an example down below. So in the scalene triangle, there's no symmetry to it. There's no congruent sides. Isosceles has a line of symmetry down here. The two sides on the side are congruent. Now, this base side does not have to be the same length, okay? So that side may be a little bit smaller, it may be larger, okay? And then there's equilateral triangles, where all three of the sides are the same length. Okay, acute. Acute means that all the angles in the triangle are less than 90 degrees. In other words, it's all acute angles. Okay? An obtuse triangle means that one angle is larger than 90 degrees. Now, any triangle cannot have more than one obtuse triangle or obtuse angle, so only one angle is going to be larger than 90. It's a right triangle if a single angle inside the triangle is 90 degrees, okay? And it's equiangular if all the angles are the same measure. So an equiangular triangle looks like this, and what we're going to find out soon is that each of these angles must be 60 degrees. Okay? Obtuse means that one of the angles is larger. This angle is bigger than 90 degrees. That makes it obtuse. This is a right triangle because one of the angles inside is 90 degrees. And acute means that all the angles are less than 90. Okay, so the sum of the measure of the interior angles of a triangle is always 180 degrees, okay? In other words, this angle plus this angle, all three of the angles, must add up to 180 degrees. That's how we create a triangle, and it's true for any triangle. Could be scalene, equilateral, equiangular. It's the same for all of them, okay? All right, so the exterior angles theorem says that the measure of an exterior angle of a triangle equals the sum of the measures of the two remote, non-adjacent interior angles, okay? So, in other words, this angle 1 is going to be the same amount as angle B added with angle A. Now, let's think about why. Angle 1 and this angle right here, the one at point C, these two must add up to 180. Do you agree with that? So this angle, which we'll put a question mark, plus the measure of angle 1, these two together must be 180 because they're supplementary. They form a linear pair, okay? So if those two added up equal 180, plus A and B added with this other angle also equal 180. Therefore, this angle 1 plus A, or should be the same amount as the angles A and B added together. Okay, so a corollary to this theorem is a statement that can be proved easily using the theorem. So the corollary to the triangle sum theorem is that the acute angles of a right triangle are complementary. Now, let's see how that happens. So we know that the measure of angle A plus the measure of angle B plus the measure of angle C, all three of the angles inside of a triangle must add up to 180 degrees. Now, if it's a right triangle, and specifically in this one, we know that this angle, measure of angle C, is 90 degrees. So we're going to rewrite it. It's going to be the measure of angle A plus the measure of angle B plus, instead of measure of angle C, we're going to put 90 because we know it's 90 degrees, equals 180. We subtract 90 from both sides, and we get that the measure of angle A plus the measure of angle B equals 90 degrees, okay? So they must be complementary. So the two angles inside a right triangle that are not the two acute angles must add up to 90. They must be complementary. Okay, so we're going to state whether the triangle has two acute. We're going to determine whether the triangle with the two angles given has an acute right or an obtuse triangle, okay? So 55 and 43 are the first two angles. Those two are both acute. So how we find the third one is we do 180 needs to be equal to 55 plus 43. And then we'll do plus the measure of angle 1. We'll call angle 1 the last angle for each of these, okay? So in order to find the measure of angle 1, you subtract 55. You're going to get 125 equals 43 plus the measure of angle 1. Subtract 43. 43. And you're going to get 82. So the measure of angle 1 is 82 degrees. All of these angles are acute, so therefore letter A must be acute. Okay? In angle B, when you do the same thing, when you take 180 and you subtract both of those angles from it. Okay, for the second one, we do the same thing. So we're going to do, we know that the entire triangle has a sum of 180 degrees. So we're going to do 180. We're going to subtract the two angles that we know. So subtract 47. You're going to get, this becomes a 7. This becomes a 10. 3, 3. So 133 degrees. And then also subtract 43. You're going to get 0. This is going to come a 9. So 90 degrees. So our last angle must be 90 degrees. So if this is the case, if we have these three angles, one of the angles is a right angle. It's 90 degrees. Whoops. One of the angles is a right angle. It's 90 degrees. So this is a right triangle. Okay? And for C, if we have one angle of 80, one angle of 75, we do 180 minus 80, which gives me 100. Subtract 75, we get 25. So my last angle is 25. All these angles are acute, so it's an acute angle. For D, if we have two angles, their angles are 33 and 33. We do 180 minus 33. Cancel, this becomes a 7, this becomes a 10. 10 minus 3 is 7. 7 minus 3 is 4. 1, bring down the 1. 147 minus 33. So we're going to get 4, and we're going to get 114. So our last angle needs to be 114. That angle is obtuse, so this is an obtuse triangle. As long as one of your angles is obtuse, it becomes an obtuse triangle. And then for E, we have 24 and 66, so 180 minus 24. 10 minus 4 gives me 6. 7 minus 2 gives me 9. Oops, 5. And bring down the 1. Subtract 66. 0. This becomes a 9. So our last angle is 90 here as well. That makes it a right triangle. So that one's right as well. Okay. So we had right, acute, obtuse, and right. Okay. Next, we've got some figures. Find the measure of angle A. So angle A is down there. Well, it's part of this triangle. And we know all three of the angles in this triangle must add up to 180. Now, I noticed that there's a triangle over here as well. And this triangle will help us figure out the measures of the other triangle. Because right now, all we have in this blue triangle is this angle of 50, okay? So let's go ahead and use this other triangle to help us figure out. We know this one's 80, this one's 50. So we know inside this triangle, this missing angle can be found by doing 180 minus 80, which gives us 100, and then minus 50, which gives us 50. So we know that this angle must be 50 degrees. The angle vertical to this one must also be 50 degrees. Because they're vertical angles, they must be congruent. So since those two are vertical, they're congruent. We know that this angle is 50, this one's 50. We can figure out the last angle by doing 180 minus both 50s, so minus 100, gives me 80 degrees. So this angle must be 80 degrees. So the measure of angle A is equal to 80 degrees. Okay, letter B, we're still finding the measure of angle A. Now, we know that this angle is congruent to this angle. We know that this one is 40, this one's 40, this angle is 60. Now, regardless of what this angle is, let's say it's X, for example, okay? We know that 180 equals X plus 40 plus 60, okay, for this angle down here. All three of those angles added together should give us 180. So we have 180 equals X plus 100. Subtract the 100 from both sides. You're going to get 80 equals X. So that means this angle up here is also 80 degrees. If both of those angles are 80, then these are the exact same triangle. So they have all the same angles. That means angle A must also be 60 degrees. Okay, same thing over here, okay? We matched up this angle, this angle, this angle. These two are congruent, so this missing angle must also be 110. All right, find the measure of angle A. So this is where we apply the exterior angle of 120. So we know that this exterior angle must be the same as the sum of this angle with this angle. So the measure of angle A plus the 80 degrees from this angle is going to be equal to 120. So how we find angle A is we subtract 80 from both sides. And we're going to get the measure of angle A equals 40 degrees. Okay, in EFG, the measure of angle G is 100 degrees. The measure of FEH is 3 times the measure of angle F. Find the measure of angle F. Well, let's set up an equation. So this is going to be the measure of angle F. We know that 3 times the measure of angle F equals the measure of angle F plus 100, because these two angles added together should give me the exterior angle over on the other side. So we set this up. All we have to do is we would be like, okay, let's subtract the measure of angle F from this side. Let's subtract the measure of angle F. 3 minus the 1 from here would give me 2 times the measure of angle F equals 100. Divide by 2, divide by 2. You're going to find that the measure of angle F is 50. Okay? We basically just treated the measure of angle F as if it was X, right? Because if this is 3X equals X plus 100, you know that you just need to move X over to this side. You subtract X, you get 2X equals 100, and you solve, okay? Treat whatever angle is missing, treat that as a variable, and then it's much easier to solve. Okay, and that's it.